All right. Good morning from Indianapolis, Indiana. Thank you so much for everyone who's joining us today. I see people who are popping on right now. I'll just give a couple of seconds here for people to join before we jump into our webinar for today. I'll just start with kind of a quick overview of what our agenda is going to be this morning. We'll start with a short presentation about IU Indianapolis, and then we'll dive right in with our featured speaker today to talk about physics. So as you're joining, if you would introduce yourself, maybe your name and where you're watching our webinar from today, that would be fantastic. You can just type that into the chat. We will be monitoring the chat throughout the webinar, so that's where you can type in any questions that you might have, either for myself or for our faculty presenter. We will be streaming live today on LinkedIn and on YouTube, and you will also be able to go back and watch the recording of the webinar after the fact as well. So we may have some folks who are watching the recording as opposed to watching it live. But thank you all who are here watching live. I'm already seeing we've got a couple joining from Pakistan, one from Nigeria. I love seeing the diversity among our webinar participants. So I think we will go ahead and just hop right in and get started. We want to make the most of our time here this morning. So I'll just quickly introduce myself. My name is Kelly Sumner, and I'm the Director of International Admissions here at IU Indianapolis. So I oversee the team that does both recruiting and also application review for all of our international undergraduate and graduate students here at IU Indianapolis. So I'm just going to take a few minutes here at the top of the webinar to tell you a little bit about IU Indianapolis before I turn it over to Dr. Decca. So let me share my slides here. Actually, all right. Excellent. Okay, so as I mentioned, I work here at IU Indianapolis in Indianapolis, Indiana, which is in the Midwest part of the United States. If you're not familiar with where Indiana is, our nickname is Crossroads of America because we are kind of in the middle. And we also have the most interstates running through our city of any city in the United States. Fun fact about Indianapolis. But our university is a fantastic urban university. So IU Indianapolis is actually located in the heart of downtown Indianapolis. You really are about 15 or 20 minutes away from pretty much any place you would want to get in the downtown area. Huge advantages to our students to be close to all of the various companies, organizations, and resources that are here in downtown Indianapolis, both for things related more to your studies and potential career opportunities, but also for things like shopping and museums and festivals. It really is an excellent location. We are, like I said, steps from downtown Indianapolis. So lots of things to do in the city for students, but we also have a lot of things for students to do here on campus. So in addition to your academics, which obviously are the priority for most students, we do also have NCAA Division I athletics. And we also have lots of intramural and club sports and a lot of fun athletic related activities for students to do on campus. And we also have lots and lots of student clubs and organizations to participate in. So at last count, we had 37 international and multicultural clubs, but there's pretty much a club or an organization for every interest every hobby that you might have, you're going to be able to find some like-minded students on campus. If there is something you're interested in and there's not a club or organization for it, there's a pretty easy process to start your own club. So that's always an option as well. This is a quote from one of our recent graduates from Brazil. She says that she recommends to anyone to come and receive an excellent education at IU Indianapolis. She actually graduated with a degree in law from our law school and has started her own law firm here in the city of Indianapolis. So that's a pretty exciting success story. We are a pretty large university. We have around 20-ish thousand students here on campus. As far as our international student population, we have over 100 countries represented and about 1,900 international students. We did recently get our official designation as an R1 research institution, which is a big deal. That means that we are generating all kinds of research across disciplines, and we're getting funding, grant funding, to support that research. So I'm pretty sure Dr. Decca will give us some good specific examples of research that he's done and is happening in his department. But that's a pretty big deal to be an R1 research university, in addition to being a premier urban university here in Indianapolis. So in addition to physics, which is in our School of Science, Dr. Decca is going to talk to us about physics today. We have hundreds of academic programs to choose from here on campus. So we offer intensive English programs for students who need to work on their English a little bit before they can enter into an academic program. And then we have undergraduate programs. We have graduate programs, both master's and PhD programs here on campus in a wide variety of areas. Some of our most popular, highly ranked programs are things like science, health, business, technology, liberal arts. But we really have a little bit of everything for everyone. We do have the largest school of medicine in the United States here in Indianapolis, the IU School of Medicine. We have the only dental school in the state of Indiana, also here on campus. So although we have a lot of different areas of study, it does seem like a lot of the research happening across campus is related to medicine, healthcare, improving health outcomes, biotechnology. So kind of like that intersection of health and technology seems to be like kind of our sweet spot in terms of research here on campus. Just a few other statistics. One of the things we really emphasize for students is it's important to find opportunities to learn outside of the classroom. So whether that's participating in research, there's a lot of opportunities both at the undergraduate level and at the graduate level for students to participate in research with the faculty members in their department. We also encourage students to get internships while they're studying. So that's an opportunity all students can take advantage of. International students can start looking for internship opportunities during their second year of study. And we find that about 75% of students take advantage of opportunities to do hands-on kinds of experiences like that outside of the classroom. It's a really important thing for your learning experience, but also something that you can use for your resume and to kind of boost your prospects when you go out into the job market once you graduate. For undergraduate students specifically, the application process and requirements are fairly straightforward. You're going to submit an application to IU Indianapolis by using either the Common App, or we have an application that's available on our website called Apply IU. There's a $65 application fee. Once you apply, you're going to upload your supporting documents. So we're going to require copies of your academic records and proof of English proficiency. We do not require SAT or ACT, so we are test optional for those tests. Once you receive your admission decision, if you need an F1 student visa to come study in the US, we'll ask you for your financial documentation, and then you'll be able to submit your enrollment deposit and start through our pre-arrival process, doing some online orientation and We'll walk you through the steps that you need to go and apply for your visa, and help you get ready to come to the US and to Indianapolis to start your studies. For graduate students, if you're a prospective graduate student looking at potentially a master's or a PhD program, the process is somewhat similar, except you start by applying and working directly with your department, with the program that you're applying to. So every graduate program may have slightly different requirements. They may have slightly different deadlines. Most of that information is pretty easily accessible on their website. But if you are looking for information about a specific graduate program, you can always start with my team in my office, and we can connect you to the right people if you're not sure. We do offer financial aid, scholarship opportunities for international students. At the undergraduate level, we offer merit scholarships to undergraduate students if you apply by February 15th for a fall intake. We actually don't offer scholarships to students who apply for spring, only for fall. So that's an important thing to keep in mind. Those scholarships range from about $5,000 to $10,000 per year. And we also have competitive scholarships that are offered, again, for undergraduate students, incoming freshmen, through our honors college. And those scholarships are quite a bit larger, that range from $19,000 up to full tuition. Once you're admitted to IU Indianapolis, if you meet the qualifications for the competitive honors college scholarships, we will send you instructions about how to apply to the honors college and potentially compete for those higher scholarship amounts. On the graduate side, that is, again, very department specific. So if you're looking at a master's or a PhD program, you're going to want to talk with your department about any potential scholarships or funding opportunities. It's not guaranteed, but I know many of our graduate students do take advantage of opportunities for graduate assistantships. Sometimes you might be able to get a teaching assistantship or a research assistantship. Many, but maybe not all, but many of our PhD students do receive a lot of funding that comes through those research grants that the faculty are getting for the research that is happening in our departments. So if you're an undergraduate student, the application timeline, if you're looking at a fall start, we do have fall and spring intakes. So we start, the fall semester begins in August and the spring semester begins in January. If you're looking at starting in August, the final deadline to submit your application is May 1st. So it's not too late. If you're looking to start this coming August, we'll still accept applications. But in general, our application opens in August. So if you're potentially thinking about coming for August of 2026, that application will open up August 1st of 2025. We accept applications all the way through to the following May. There are a few other deadlines in there. If you're somebody who's interested in potentially competing for those honors college scholarships, we want you to apply by December 15th. So we can get your admission done and make sure you're in that process in plenty of time. February 15th is the final deadline for merit scholarships and the final honors college deadline. So it's important to keep that in mind if you are wanting a scholarship. And then, like I said, application deadline of May 1st, and then you start in August. Graduate programs will have a slightly different timeline. Like I said, most of those will have their deadlines posted on their website. I think it's always smart to ask if you have missed a deadline. It's worth sending an email and saying, hey, I know I missed the deadline. Is it still possible to apply? There are some graduate departments I have seen recently who have said, yeah, we'll take a late application. Or they might say, no, you're going to have to wait and come in the next available term. But it's always worth asking. So that's my advice for prospective graduate students. So that kind of wraps up the quick overview of IU Indianapolis. On the screen, the QR code that you see there will take you to our link tree, where we have kind of highlights of some different links and information that might be valuable for prospective international students. So feel free to check that out. My team is always ready to answer any questions that you have, especially if you have really specific questions. You can just shoot us an email, iapply@iu.edu. Will come to my team, and somebody will get back to you pretty quickly with answers to your questions. If you're a prospective graduate student, like I said, we're happy to kind of connect you directly to the department, make sure you know where to go to get that specific information that you're interested in. And then just a reminder about those application deadlines, May 1st for undergraduate students who are wanting to start in August, and December 1st is the deadline for undergraduate applications to start in January in the spring. It looks like Adesola, I've got a question in the chat from Adesola saying that you're struggling with being able to apply. My recommendation would be send us an email, Adesola, at that email that's on the screen right there, iapply@iu.edu. So we'll be able to help you figure out whatever, we'll troubleshoot what's not working for you. Sometimes we're able to figure it out. Sometimes we have to get a tech person involved depending on what the problem is, but we'll get you sorted out, no problem. So I'll just leave this up here on the screen for a minute, make sure everybody has a chance to jot down that email address. The recording will be up later if you want to come back to it as well. But now that my portion is over, I'm going to do a little introduction for our guest speaker today. So let me unshare my screen now. So I'm so excited to introduce to all of you Dr. Ricardo Decca from our physics department here at IU Indianapolis. We're very excited that he agreed to get up early on a Saturday morning to come and share some information with all of you about our physics programs here at IU Indianapolis, all of the opportunities that might be available to you if you come and study physics here. And then I think he's also going to talk some about his own research as a good example of what you might be in for if you're coming to study in physics. So thank you so much, Dr. Decca. The stage is yours. I'll let you do any additional introductions for yourself that you want. But we're looking forward to learning more about physics today. I'll add your slides here for you, and then it's all you. I will actually, before Dr. Decca gets started, let me just say again, if you have any questions while Dr. Decca is presenting, please feel free to type those into the chat here in StreamYard. And we'll either answer the questions maybe midway through, or we may hang on till the end, and then we'll have kind of a Q&A session, and we'll ask those questions that came into the chat at the end of Dr. Decca's presentation. So please don't be shy. Any questions that you have about IU Indianapolis, about physics, about any of the information Dr. Decca is about to share with you, please do type those into the chat, and then we'll get your questions answered. All right, over to you, Dr. Decca.
All right, thank you very much, Kelly. Thanks for the nice introduction. Welcome, everyone. I'm glad you are here sharing this presentation. I'm Ricardo Decca. I'm a professor and chair in the Department of Physics. As you can probably tell, I went through a path that probably some of you will do, coming from another country to the United States. I come from Argentina. I actually did all my education, including my PhD in Argentina, and came to the United States for a postdoc a long time ago, more than half my lifetime. I came in 93. I came to Indianapolis in 2000 as an assistant professor. I have been progressing through the professional ranks since then. And I want to share with you what we have to offer here in the Department of Physics. I have there the general link for the Department of Physics, and I just posted in the comments a specific one for if you want to apply. There are two links in the application, one for undergrads and another one for grad. In the one for grad, actually the application goes to the graduate school in the IU Indianapolis, but then there are specific requirements that are listed on that link. You can see that Indianapolis is a vibrant city, and that is really the center of the city. The picture that you're seeing is the center of Indianapolis. I can tell you that both Indianapolis and in particular our campus have changed a lot in the 25 years I have been in here. The city has become much more vibrant, and the campus has become really beautiful. It is really nice to come in the mornings and walk a little bit before getting to work. Let me tell you a little bit about the department. We are, for physics terms, a small department. We are 15 faculty members, 10 doing research, and 5 which are just teaching focused. We have a reasonably large amount of equipment, 650 square meters of laboratory space, and also we have a footprint in the new buildings that are coming up constantly, pretty much research base. And we have NMR and EPR spectrometers, ultra high vacuum deposition analysis system, scanning electron microscopy, uh, atomic force microscopy. Anyways, the usual characterization and research tool that you can think of. And we have interactions with other departments here in the School of Science, other units within campus, but also with other universities in Indiana and throughout the United States. This past Monday, I'm an organizer of a Center for Quantum Technologies, and this past Monday and Tuesday, we had our meeting that took place at Purdue University, in which we are trying to use quantum technologies to improve the development in different areas, including, for example, medicine. Student-wise, we have about 40. It varies a little bit, but between 40 and 50 bachelor students. The number of master students is usually small, but typically what happens is our 25 or so PhD students, on their way to getting their PhD, they get first a master's. Funding, we get funding for many different national federal agencies like National Science Foundation, but also NIH, National Institute of Health, Department of Defense, Department of Energy. From private foundations, Borax Wellcome Funds, DJ Angus, Packard Foundation, and also we get funding, some internal funding from the Office of the Vice President for Research. The academic programs that we have, as I mentioned before, a BS in physics. Typically, this takes, like most bachelor degrees, takes 4 years, 120 credit hours that you have to do over 4 years. There are different plans, and the good thing that it was completely foreign to me when I came. As I said, I didn't do my education here, but it was foreign to me when I came to the States. In Argentina, if you do physics, after I finished high school, everything I was doing was physics and math. There was nothing else. In here, there is a lot of room for you to investigate other goals that you might have. And for example, within the department, at the bottom, I saying that you can get a major or a bachelor in physics, but you can also do a minor in physics or a minor in astronomy. And when I say this, all programs in the university have these specific minors. So many of our students have a major in physics and then have a minor in philosophy or in health science or any other thing that if you plan and you work with your advisors, you can fit it within your 120 credit hours and you can get 1 degree. Or if you see in here, you can also get dual degrees. You can have a BS in physics and in mathematics, or in physics and mechanical engineering. We have a concentration in biophysics, and we are also planning, and we hope that these were going to come up on board by fall 2026, a computational physics concentration, and also a Bachelor of Science in Astrophysics. Besides this program, as I mentioned before, we have a master's in physics and a PhD in physics. For our PhD students, they are supported. We guarantee support to pay a stipend, which is not large, but also all the tuition for 6 years. Most of that is done by research assistantships. Typically, in the first 2 years, you are taking classes, and then during those 2 years, you are supported with a teaching assistantship. So you're taking classes, you're taking courses, required courses to get your PhD. These are typically courses in classical mechanics, quantum mechanics, statistical mechanics, and thermodynamics, mathematical physics, courses in mathematics. So again, these are all courses that are needed towards getting your PhD, and then specialty courses which are more associated with your specific research. This could be more quantum mechanics, quantum field theory, specific techniques on nuclear magnetic resonance, whatever is needed for have a complete formation in your career. After about 2 years, you are more or less done with your courses, and then you concentrate exclusively on research. And you, as I said, you get paid a small stipend for that. You're not going to get rich, but you're not going to have problems also buying your groceries. That is what we always tell our students. Some of our graduate students are married, have kids, and they can support themselves with their stipend. And bear in mind also, you get your tuition covered. So why to do physics? Well, I might be a little bit biased, but it is a lot of fun. You get to really understand the intricacies of the universe, and you get to play with very expensive toys in the lab if you're an experimentalist, but also with very high-end computers or developing new theory. And like in all research, all of a sudden one day you realize after long hours of work, you are the first one who has ever realized that very specific thing you have been working on. And it is a fantastic feeling. And when I say that you realize that, I'm not just talking of myself. In my lab, for example, I have 2 graduate students, I have 1 postdoc, and I have 7 undergraduate students. And they are doing research from the first day they get into Indianapolis. There is a very nice program that if you come to our undergrad, if you come as an undergraduate, you should sign up for it. It's called First Research Internship Program, or one RIP, and you can jump into a lab. It doesn't need to be your specific topic of on your career, but you just sign up and you start doing research. Doing research gives you education in an area that classroom teacher cannot do it. As a physicist, you can work in different research areas within the department. We have condensed matter and biophysics, so we call this the matter area on our department. We work on biological membranes, advanced microscopy, material physics. In material physics, I want to emphasize you can do, for example, jump into spintronics, which is a new way of doing computation, but instead of working with the charge of the electron, you work with the spin. And the point is that when charges move, they dissipate. When spins move, they don't. So we hope that our research will contribute to enhance and improve computation in the future. You can do laser and optical physics, a lot of nonlinear optics, how to encode secret messages in something that looks like this noise, how to do quantum information cryptography, how to do quantum information transmission of information at a distance, this spookiness that if you create entangled entities, you keep one, send another one, and then you transmit the message when you do a measurement in your system. I particularly work in fundamental forces and precision measurements. There are in theoretical physics how to work in open quantum systems, and as you can see, I'm sorry about my voice, but I have been dealing with a cold for a couple of weeks, and it's a little bit rough. And you can see most of our projects are, as I said before, are federally funded. And as I mentioned before, as a student, you will get paid by federal agencies to conduct your research. What happens after graduation at IUPUI? Most of our majors, most of our bachelors go on into graduate school, and if not, they start their career working typically as technicians and local companies. We have Allison, Cummins, Rolls-Royce, Lilly, or some of our graduates want to go into teaching, and they go teaching at high schools. Our master's graduates typical, as I say, they get a master's on a way towards their PhD. But some of them have gone also to work in local companies. Our graduate students, when they graduate, they get a postdoctoral position at a university or at another university, or the Department of Defense labs, or the national laboratories. And typically, after their postdoc, they go into industry, or they become professors, as it was my career. So, how good is to be a physicist? This is what happens. I'm going to show you some statistics as a physicist. This is not for our graduates. This is accumulated for the United States, and all this data comes from AIP, the Institute of Physics, the American Institute of Physics. So in the left, you see some of them go into graduate study. A good number in physics and astronomy, but you can see that physics also prepares you to become a graduate student into other fields. About 50% after 1 year become employed, and about 4% in the first year are unemployed. One statistic that this is not show is that after the second year after graduation, basically the unemployment among physics graduates is zero. You learn skills in physics that prepare you to, I'm going to actually boast in here, to do pretty much anything you want to do. You learn to think critically, and then you apply that in different fields. Where do you go to work? Well, a good number go into the private sector, on a college or a university, a high school. Some of our students go into the military, or in a civilian government national lab. These are the skills that you learn in your career, and then how you're going to be in different areas, how do you apply them. If you take a look, a lot of the work is associated with computation. You will work and do a lot of computation in your major, and certainly in your PhD, and that can be applied to any other area in the workforce. And finally, these are all data for bachelors, the field of employment that different people have. Very many go into engineering, computer software development. About a sixth of graduates, of physics graduates, going into computer software development. Some in education, in physics and astronomy, etc. So again, this is a glimpse of all the areas that you can work on with your bachelor's in physics. Now, why to go into PhD? Oh, I'm sorry, the last one. This is roughly the starting salary that you will get as a bachelor with a bachelor degree in physics. The salaries are good, but it's a motivation to go into PhD. You have to invest more time, but you will see that the salaries will be much higher. If you can see here, salaries are on the order of $60,000, a good salary. But if you go in and get a PhD, and again, your initial employment as a PhD, most of you will go and take a postdoctoral position. A good number, a little bit under 50%, go into a permanent position. Some will go into other temporary positions, like a temporary staff member on a lab. And again, a very small number the first year will be unemployed, but in the second year, that unemployment rate is basically zero. This is what fields you will go and work. And again, very many will go into physics. Some will go into physics, but not in the area in which they got their PhD. And some other will go really into other fields. And if you can see, at the end of your career, even if you got your PhD in physics, about 2/3 of PhD in physics work in an area which is not physics. Really, you will get a preparation that will allow you to go into pretty much any area. We have PhD students working as MD doctors, as lawyers. And you say, lawyers? Yes, patent lawyers. You will be probably the best prepared person in a patent lawyer office in order to distinguish if that patent can survive or not. So really, the preparation is really, really deep, because you not only learn what to do in your field, you learn really how to think critically. And that is something that is very well sought after. And finally, here now are the salaries. You see, they have jumped a lot. Now, a typical starting salary for a physics PhD graduate in the private sector is in excess of $100,000. So that now is something very respectable. And you get typically, even as a postdoc, you will get starting salaries which are on the order of $80,000. So really, that is a motivation to go into physics, a PhD in physics. I will make a pause here. I don't see any questions, but I will, if you want to take 30 seconds and ask questions about this. If not, I will use the last 20 minutes or so to tell you a little bit specifically why physics is so great. And I will use as an example my research. And again, because it is the one I know the most, I just want to give you a glimpse on why it is so exciting. Doesn't seem that there are any questions. So I specifically work in the field of gravitation. And I look into explain fundamental things that we don't understand or we have not tested. And I call this a trip into the dark side, because you know that, well, you might know that of the part of the universe that we see, we can only see 4% of the universe. The rest is composed of what we call dark matter or dark energy. And actually, I am one of the persons that I did my PhD in one area, and I'm not working in the same area. I did my PhD in condensed matter, and eventually I'm working in something which is gravitation. And I say here, blame Ephraim Fishbach. Ephraim Fishbach is a colleague. He came and gave a colloquium. And as he was giving the colloquium here in the department, I said, that is an area in which I want to work on. And it was risky. I was in my first year as an assistant professor, and it changed completely the direction of my field. And I have to say that I have been quite successful. I have had funding from National Science Foundation pretty much throughout my career. I have worked in close collaboration with a national lab, Argonne, and another one, Los Alamos. And I also have had funding from Department of Defense and Department of Energy. And what we do is quite simple. But let me give you a little bit of a glimpse of why this is important. And what I have in the left is what we call the standard model of cosmology. This basically explains what we think is pretty much everything except that it has holes. This explains from the Big Bang, what happened from the Big Bang from 10 to the minus 42 seconds after the Big Bang until nowadays. And you have here one thing that is called the graviton. In the standard model, there will be a particle that mediates with mass and produce gravity, except that we have not seen it. And then it has to be there, but we have not seen it. And then here what we have on the right is gravity really right? And here on the y-axis it says, well, if this alpha goes to 0, it has to be right. And if it doesn't go to 0, it just it just could be something else that we don't know yet if it is there. And then in that range, yes, we know that gravity works well. But if we go to short separations, we actually don't know. And then what we do experiments to test that. So we have here a microelectromechanical system with a small sphere glued to it, and then a turntable. And then I want to show here that I decided on that talk that we could do better. But when I say we, I asked one of my friends, one of my colleagues, to do this microelectromechanical system. I asked another friend to make a low noise amplifier in order to get the signal. And I made another friend to do these samples. And then I had to do the measurements, right? So this is really a collaborative enterprise. These people were from a private company, the one that did the low noise amplifier. This was from Alcatel. a friend from a national lab, a friend from another national lab, from the National Institute of Standard Technologies, and we do the measurements. But we had to put the separation between this rotating plate and this sphere is very, very small, is 200 nanometers. So a nanometer is 10 to the minus 9 a meter, so 10 to the minus 9 a yard. So the separation is very, very tiny. You cannot even see it under a microscope. We put them very close, and in that range we have something which is called vacuum fluctuations. Vacuum fluctuation basically is something that if you put two surfaces close to each other, there are these photons that appear and disappear, and as an effect, these plates will get close together. This is the same thing that happens between, if you have two boats, two ships, there are more waves coming from the outside than there are between the ships, and then the ships get pushed together. So this is a force we have to deal with, and in fact, our measurement of this Casimir force is the best one in the world. But let me tell you this chronology of research to give you an idea that research takes a long time. In 2003, I watched that talk in 2001. In 2003, we got our first results. It took 2 years to develop a system. In 2005, we improved our results and became 2 orders of magnitude better than anybody else in the world. In 2007, we kept improving our results and improving our results. In 2009, we realized our method wasn't good, changed the method. Finally, in 2010, our results were finally reproduced by other group. So it took about 7 years from our first result to somebody else to come close enough to say that our results were good enough. And that's something that you need in research. You need for somebody to reproduce your research. We keep doing. If you have questions, I can tell you, but in 2014, we produced the first limits to date of dark energy and dark matter existence. And then in 2016, we started asking, why is the gravitational constant so bad, so poorly defined? And we opened yet another area of research. And then we asked ourselves, can we measure if gravity is really quantum? Finally, in 2020, our first result from 2003, they were the best experimental results. They were not understood. They seemed to be wrong. Finally, in 2020, people realized that the experiment was right. What was wrong was the theory. But as you see, it took 17 years of research just for people to realize that the results were incorrect. Let me tell you a little bit more about this with things that we call short-range gravity. So in this experiment, we have this, we think of it as a spring and a mass, and then we produce an excitation, and the excitation is this thing that we have underneath. It's a collection of the orange and yellow is gold, the rest is silicon, and all this is covered with with silicon. And what we have on the left, on the right, is what theorists think that could be modifications to gravity. The thing that you see here called moduli, the strange modulus and gluon modulus, are predictions from string theory. The other thing that you have, the dilaton, the radion, the gauge baryons, these are all predictions that can come from supersymmetry. And there are more. As I said before, this alpha being 10 to the 0 means gravity works well. This alpha being larger means we are ignorant. We don't know if gravity works well. And if in the left here, if this lambda is 10 nanometers, it could be that alpha is 10 to the 19. So what does that mean? We really don't know if gravity will work. Could be 19 orders of magnitude and of something else being present there, and we don't know if there is something there or not. So we have to keep working. Our approach is the best in the world. You can see this red line here, compared with researchers at University of California, Riverside, at Yale University, at Stanford University, at Washington University. We are the best, but really we don't know much. We have to go still 8 orders of magnitude to show that gravity works or to find something new. It will be much more exciting, but we have to yet see if that is the case. So, how do we keep going? Well, instead of doing with these mechanical springs, if we with a classical spring mass system, we are not going to be able to go down. We might be able to go an order of magnitude more, but we'll not be able to go much more. So how do we keep going? We make a quantum spring. So what we do is we trap a small particle in what is called an optical trap, and we cool it down. We cool the center of mass of that particle so much that it becomes these quantum levels that are in a spring become noticeable. And then we prepare a system in this superposition, or if we put two of these systems in an entangled state, and then we get a lot of extra resolution in the measurement. And why can we do it and other people can? Well, because of everything in experimental research, we have realized something that other people have not yet. When we trap a particle, some of the light that is used to trap the particle gets absorbed by the particle, and the particle gets too hot. You have to cool it down, and that is what we can do, and then increase the trapping potential and let us go into this quantum regime. So if we go there, we expect this new red curve. The black curve is the old red. This new red curve has not been yet measured. This will be IU Indianapolis in 2020, some time in the future. And I hope it is 2020 something and not 2030 something. But we'll get there, and still we'll get much closer, but not yet into this alpha equals to 1. We are planning already how to do new approaches to get us even closer and closer and closer to this alpha equals to 1, but we will see if we can get there or not. So one of the approaches is do very strange things that we modulate masses, and then we produce a signal that gravitational will be way above this gravitational quantum or way below, and then combining this, we actually think we'll get to alpha 100. Not quite 1, but very, very, very close. But the point is that this is going to be very far in the future. I will expect 5, maybe 7 years from now. And we have to just keep doing incremental steps, making sure that all these steps are correct. So everything that we do is correct, and we can continue to build up on our research. So with that, I will thank you for listening to my presentation, and we have some time, still sometimes, for questions you might have thought to ask Kelly or myself in the comments. Thank you very much.
Thank you, Dr. Decca. That was really fascinating. I think when we were preparing for this webinar, I mentioned that I wasn't necessarily a science student in high school, but I found my physics class to be the most interesting and fascinating. I had an excellent physics teacher. And so your presentation, especially talking about the research, was very, very cool. Thank you so much for sharing that with us.
Welcome. And the good thing is that even students that can just start, they don't need to get started, they don't need the full mathematical background, they can start doing research and progressing and learning. So I think that is very, very good that all students can start doing research right away.
And I don't see any comments in the chat. Please feel free, if you have some questions that you'd like to ask, go ahead and type those into the chat now. But I was wondering, kind of related to what you were saying, Dr. Decca, when I'm talking to high school students especially, sometimes they're a little bit concerned about their preparation for their major. So they might say, like, I really love physics, but we only have one physics class that I was able to take at my high school. Can I still come to IU Indianapolis and study physics if I don't have a really strong background in it already based on my high school curriculum? So how does that work if a student comes in and
The
they're
answer
not
is yes. We
excellent?
we work in a close connection with the department. I mean, the physics is not so much a problem. Certainly, students that can better prepare in physics can progress faster. Typically, it is the math which is an issue. And then when students get admitted into IU Indianapolis, they get placed. They take a test, a placement test in math, and then they get placed in what kind of courses in math they have to start. Do they need to start with algebra? Can they start with pre-calculus? Can they go directly into calculus? In order to start doing the physics introductory courses, you have to start doing calculus. It is like, can I can I write poetry without knowing a language? And the answer is, well, you first need to learn the language, and then if you have the skills, you will learn how to write poetry. This is the same thing. I mean, in order to do physics, which is an advanced kind of scientific achievement, you have to learn the language, and the language is math. So, but yes, you can take those courses and then start jumping, or getting your, before jumping, getting your toes wet. And then eventually, yes, you jump directly into the lake and you get to do the fun part, which is the swimming.
Excellent. Excellent. Um, what would be, if you had like one piece of advice that you would give to a high school student who's considering doing a bachelor's degree in physics, maybe a piece of advice of something that they could do to better prepare themselves while they're in high school, what would your advice be for a student like that?
If you are in your early stages of your high school and you want to do physics, try to certainly plan your high school, your 4 years in high school, in such a way that you do take as much math as possible and you do take physics. Also, don't be shy. Talk with your physics teachers. Very many of them have connections with actually physics faculty at universities. For example, we do have internships during the summer for physics high school students. So be prepared, read as much as you can, but get in touch and talk with people. Don't be shy contacting your physics professors are nearby universities. I get contacted by high school students pretty much 3 or 4 per month, sometime a couple per week. In, okay, what do I have to do? I'm interested in this topic. What should I be reading? What should I be watching? Then there is another word of advice: be careful with what you watch and think it is correct on the web. Most of the stuff is correct, but there are some things which are really, really incorrect. So contact your physics teachers in high school and ask them, is this really true? Sometimes, so my piece of advice is, don't listen to bad advice.
That's excellent advice. I think I would agree with that. I think it's always good to approach things with maybe a little bit of skepticism and a willingness to do your own research, right? To figure out if something is accurate or true or not. Not just with physics, but I think with everything in the world these days, right? You have to do some research and get a lot of different sources before you're confident that something is actually true. I do see we have a question in the chat. It's actually related to computer science. Mohammed is asking about computer science programs at IU Indianapolis. So I can definitely say we do have computer science programs here. They're not located in our School of Science. They're actually located in our Luddy School of Computing, Informatics, and Engineering. We have bachelor's, master's, and PhD computer science programs. There are some kind of specialty areas within computer science in those programs. If you want to specialize in something like cybersecurity, there are some kind of areas within computer science that you can focus on. So that's definitely an option. And I did also, Dr. Decca, hear you say that there is a really strong kind of intersection between physics and computer science. There's a lot of computational knowledge that is required these days, and probably any scientific field. So I could imagine, although if you have any examples to share, that those might be fields that could come together quite nicely, whether you're doing a major in physics and a minor in computer science, or vice versa, potentially a major in computer science with a minor in physics. I could see that being very complementary.
Absolutely. And to add a little bit more to the question that Muhammad has posted, specifically in computer science, Ladi's school has an institute for artificial intelligence. So, artificial intelligence, machine learning are programs that are in computer science. I mentioned here that we have computational physics, or almost have computational physics. It's not directly computer science, but then I also mentioned that Monday and Tuesday I was at the Center for Quantum Technologies, a meeting. In that center, quantum computation is a big, big, big part of it. And as you can imagine, the quantum part is really started with physics. The computation is more in the part of what algorithms need to be done. So it is still not directly said, but we are developing a master's in quantum information science together with Lodi. And as it was mentioned by Kelly, yes, you can do minors, major in one, minor in the other one, with relatively straightforward. Um, so yes, that is certainly one strong possibility to be done.
I think it's also worth mentioning, especially students from other countries where the educational systems are a little bit different. I think it's worth highlighting too that most universities in the US, including IU Indianapolis, will allow students to come without declaring a major. You can come and just say, I'm undecided. I want to do exploratory. And can take classes in a few different areas. And maybe in your second year, then you decide what you want your major to be. So that's actually completely fine and not a bad thing at all, to be honest. I think a lot of students really don't know what they want to do. And it's a big decision because you're talking about kind of the trajectory of the rest of your life potentially. So they want to come in and do some exploring. Totally fine to do that. I think the fact that we kind of expect a teenager who's 17 or 18 to know what they want to do with their lives is a little bit crazy, to be honest, because you don't know what all's out there. Maybe you haven't had a chance to take classes in some of these areas that you can try out when you come to IU Indianapolis. And the other thing that I think is kind of unique to the US educational system is you could change your mind. It's pretty easy to change your major. So, like, if you came in to a major and you said, I know I want to study computer science, and you started down that path and you're like, actually, I don't really love this. I want to change my major to physics, or I want to change my major to biology, or I want to change my major to journalism. It really is very easy to make a switch within your first or second year. It gets a little bit trickier if you're a little bit further into your third and fourth year. There might be extra classes that you have to take if you change your mind at a late stage, but it happens all the time. Whenever I am talking to other folks who do the job that I do, working with international admissions, sometimes we'll take a poll, like how many people change their major. It's usually everybody in the group or almost everybody. Like Dr. Decca said, sometimes you end up in a career that isn't necessarily exactly in the field that you studied. And part of that is because when you get an education at IU Indianapolis, when you get an education in the United States, it's not necessarily just about the content. It's about all of those critical thinking skills, problem solving skills, communication skills that you get that are really going to equip you to be able to do whatever job comes your way, wherever your path kind of takes you. You're going to be really well prepared for that. So I think that in a lot of other countries, students kind of feel like they're sort of don't necessarily have a whole lot of flexibility in their path. And I think it's really important. And one of the things that really kind of sets apart the US educational system is that we build in that flexibility for you so that you can study more than one thing, so that you can change your mind. So you have a chance to kind of explore and see what's out there before you really kind of decide, okay, this is what I'm passionate about. This is what I want to do as a career for the rest of my life. Mohammed, we actually should have, if you go to our YouTube channel, all of our previous webinars are posted on the YouTube channel. And the one that we did in, I don't remember if it was March or February, but one of the most recent ones was focused on computer science. So please do go and check out the recording of that webinar. I think we had computer science and informatics. A professor from each area on that webinar. So that should give you a really good overview of those programs. If anybody has any other questions, I think we're right at time. Feel free to drop any other questions into the chat. We can entertain a few more questions. I was just wondering, Dr. Decca, do you remember like when you realized you loved physics? Was there like a particular like moment in school or something that like really got you into physics where you were like, oh yeah, like this is what I want to do? Can you
Uh,
can you trace that back to like a particular
well,
moment?
I always say that every kid is a scientist, and then at about age 12, most of the people stop being a scientist, and in part because it's just natural development. In part, I actually blame the education system, but because it has the tendency to you have to learn this and kills the curiosity-driven part. I never lost it. I never. I was always curiosity-driven. And then at some point in high school, I have a great physics teacher. But my dad was an engineer, and so I got a lot of the drive also from my dad. But then my dad said, no, no, you should be an engineer, blah, 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 blah. I said, no, I want to be a physicist. Anyways, there was a little bit of a riffraff there. And because I wasn't doing the traditional careers, right? My family was well educated, but traditional. I mean, doctors and engineers. And I was going to be a physicist who knows what a physicist does and this and that. But eventually, I stuck with my guns and I went into physics. But yeah, the decision, I cannot tell that it was taken at some point. I always knew that I wanted to be a scientist, if you wish. At the early part, I was more investigating, maybe even doing not so many good things to nature. But at the beginning, I thought I wanted to be a biologist, and then I said, well, no, I want to do things more abstract, and I like to play with toys and pull things apart, and sometimes even put them back together. And so, at some point, I said, yeah, clearly, I want to be an experimental physicist. So that was
Nice.
some point in high school.
Excellent, excellent. I like that. I think that it's good to try to keep that curiosity alive.
Yeah.
I agree. I think that we maybe need to nurture that a little bit more with the older grade levels. I think younger students come by that naturally, but I don't know. We get a little more cynical and jaded as we go through school. We got to keep that curiosity going. I see a couple of other questions in the chat. Mohammed is asking about what documents are required for applying to IU Indianapolis for international students. So I'll just quickly recap that for Mohammed or anybody else who would like that information again. So you'll complete your application either through the Common App or through Apply IU for undergraduate students. Once you apply, you're going to submit copies of your academic records. So depending on what country you're from, that might be like high school transcripts. It might be external exam results if you're in kind of like a UK-based system or taking in an IB curriculum. You'll have IB exam results, so you'll submit those. You'll also submit proof of English proficiency. So we do require TOEFL or IELTS. We also accept Duolingo. We do waive that requirement for students from certain countries. That list of countries is available on our website, so you're welcome to check that out. We don't require SAT or ACT, so we're test optional. If you do take the SAT or ACT, we can use that as your proof of English proficiency, but we don't require it. If you don't take the SAT or ACT, then you can do the TOEFL or IELTS or Duolingo to prove your English proficiency instead. So hopefully that helps answer those questions again. I think we are a little bit over time. So I want to thank Dr. Decca again for joining us. Very much appreciated, Dr. Decca. It was super interesting to especially kind of learn more about your groundbreaking research that you're doing here. Absolutely wonderful. So congratulations on your success. And I also hope that you meet that goal that you have in the 2020s something. Looking forward to some breaking research announcements sometime in the next few years. Please continue to follow up with us if you have additional questions. You can always reach out again to my team. I'll put the email address again in the chat, iapply@iu.edu. We'll help answer any specific questions that you have about the application process, about programs. We can also connect you with the department specifically. Dr. Decca has put his email address in the chat as well, so feel free to connect with him if you have some specific questions that you want to ask about physics, or you just want to have some more conversation about the cool research that he's doing. Please don't hesitate to reach out to us and connect with us as you kind of continue your journey. And we hope that some of you will come and join us here at IU Indianapolis very soon. All right. Thank you so much for joining us. Thank you, Dr. Decca.
Thank you, Kelly, for setting this up, and thank you, everyone.
Absolutely. Yeah, everybody have a great rest of your day.